Hello everyone and welcome again. As a continuation from the previous video, I just thought today maybe I should cover a little more in depth about graphs and finding the integral when you have two graphs, two functions intersecting one another. So in this particular example, we have a function y equals to x plus 2, and then we have another function y equals to x squared. We're asked to evaluate the area under the two curves, right? So the first approach, what we will do is we will evaluate at what point do the two graphs intersect, right? So what are the 2 points on the x-axis where the two graphs will intersect, and we will use those 2 points as our limit for integration. Okay, so let's go ahead. So in order to find where these two graphs intersect, we have to set them equal to one another. So we have y equals to x plus 2 and another function y equals to x squared. So we set them equal. So we put x plus 2 equals to x squared in order to find the intersection of the x values. So we can go ahead and simplify this. So x squared minus x minus 2 equals to 0. We recognize this to be a quadratic equation. What we can do, we can factor out. So it's put x minus 1 and x plus 2, right? Because minus x minus x plus 2x. So if I sorry, it's x plus 1 and x minus 2, right? Because if I do minus 2x plus x is minus x, minus 1 times 1, minus 2 times 1 is minus 2, and x times x is x squared, okay? You can use your delta or whatever works for you. Okay, so you said this equal to 0, so we said that x plus 1 equal to 0, or x minus 2 equal to 0, which means x equals to -1, or x equals positive 2. So these two values will be the the two x-intercepts for our graph. So you go ahead and select that point here. So x equals to -1 and x equals to 2. This is exactly where these two graphs intersect one another. So we go ahead and evaluate the integral from -1 to 2, and that will give us this area right here where these two intersect, right? So this will give us the area under this curve. Thing right here. Okay. Alright, so go ahead and do that. So we'll do the integral from -1 to 2 of the first. So when you have two functions, one overlapping the other one, you always take the top one minus the bottom one, right? So what's the function at the very top? Is x minus 2. Which one is at the bottom? Is x squared. So we'll take x plus 2 minus x squared. In other words, as if you're actually evaluating the area under this curve, right? From -1 to 2 of x minus 2, and then you evaluate the integral from -1 to 2 of y equals to x squared, and then you take the difference, okay? So we'll go ahead and do that. So x plus 2 as our first function minus the function at the bottom, so x squared dx. Okay, so -1 to 2, x plus 2 minus x squared dx. This will give me -1 to 2. Okay, let's just go ahead and integrate this one. So what is this integral here? So you have 1/2 x squared plus 2x minus 1/3 x cubed from -1 to 2. I hope this makes sense. Again, just to reiterate, what I'm saying is we want to find the area under this curve. So this area right here. And in order to do that, we take the first function minus the second function. So whatever function is at the very top, you subtract the function at the bottom, and you take the integral on where the two graphs intersect. So in this case, it's -1 to 2. That's why we're taking the integral from -1 to 2, the first function, which is x plus 2, minus the second function, which is y equals to x squared dx. And if this doesn't make sense, I would encourage you to kind of go back and rewatch it as many times as you like until things start making more sense for you. And again, if you have particular questions or comments, please leave in the comment section, and I will be more than happy to answer your questions. And if you need more clarification, I will be more than happy to do so as well. Okay, let's continue. So this will be x plus 2 minus x. So we just took the integral here, 1/2 x squared plus 2x minus 1/3 x cubed, evaluate from -1 to 2. This equals to 1/2. So when x equals to 2, so that would be 2 squared plus 2 times 2 minus 1/3 of 2 cubed. Now we do minus when x equals to -1, so 1/2 minus 1 squared plus 2 times -1 minus 1/3 minus 1 cubed. Again, I am just substituting x with -1, right, since we evaluate the second part. Okay, so this is one equation. Okay, so this one is, you simplify 1/2, this will be 4 plus 4 minus 2 cubed is 8, so 8/3. Now minus this entire thing. So -1 squared is 1, so you get 1/2, plus 2 minus 1 is -2, minus 1 cubed is -1, times minus 1/3 is positive 1/3. Okay. Alright, so you can distribute this minus throughout the parentheses. So we get 4/2 here is 2 plus 4 minus 8/3 minus, so minus 1/2 plus 2 minus 1/3. Okay, so this will be 6 minus, I have 1/3 and 1/3 here, so minus 8, so it will be minus 9/3. Minus 1/2 plus 2 is positive 3/2. Okay, so this will go to 3. 6 minus 3 equals to 3, plus 3/2, which is 9/2. So this will be it as our result. And I really hope I didn't make any mistake on this, and if there are, please let me know in the comment section. All right, so this will be it, and this will be the final answer of the area intersecting these two graphs. As always, thank you for watching, and if you have any questions, please leave it in the comment section. I'll be more than happy to answer any question that you may have. And if you have actually, again, any suggestions for a particular topic or a particular example that you would like me to cover, please let me know, and I will be more than happy to do so as well. All right, thank you. Have a good day.